Today in Lecture 14, we're going to consider some alternative visions of natural science. This lecture builds directly on the last one. In Lecture 13, we ended with the observation that the new science of biology opened up an innovative view of nature to natural philosophers. So the alternative visions of natural science that I want to discuss today grow right out of that development. Let me review just a few of the conclusions we came to last time. In biology, at least, as the Germans defined it, the development of living things was subject to a natural law that operated simultaneously at different levels. In particular, the law functioned at the levels of the individual and of the species, and it did so simultaneously. I mentioned another unique aspect of the law that was important to German natural philosophers. The law expressed the conviction that nature had its own inner purpose. So when they concluded that what happened in the development of species also happened in the development of the individual, both phenomena were merely following nature's purpose. The development took a direction that it did because nature itself directed or dictated that direction. Now, if you believe that this kind of law, this law of purposefulness, existed and was evidenced by the development of living things, then it would not be surprising if you gave the law precedence over other kinds of laws, specifically over mechanical laws. Mechanical laws, after all, are blind. You know what we say about machines: garbage in, garbage out. Sometimes we think machines should be smarter than that, but machines only do what you tell them to. How many times have you said to yourself, "Dumb computer, why'd you do that?" Computers don't think for themselves. They don't have their own purpose. They reflect the purpose of the one who's using them, or the one who built them in the first place. So they aren't as impressive as these new laws that govern organic forces. Those laws do have their own purpose. It was perhaps inevitable that from the introduction of a new kind of law for living things, natural philosophers would begin to reconsider their understanding of nature itself. If mechanical laws lack something that the laws governing living things possess, then maybe we shouldn't imagine nature to be a machine like we've been doing ever since Newton wrote the Principia Mathematica. Many natural philosophers assumed that nature was a gigantic clockwork mechanism that Newton had described pretty thoroughly. Nature was a machinery that seemed to be capable of running on eternally. But if this new kind of law reflected nature more completely than did those merely mechanical laws, then perhaps we should regard nature more as a living thing than as a machine. Perhaps nature is more like organisms than machines. Organisms appear to have their own purposes. If nature has its own inner purpose, maybe organism is the better metaphor for nature than its mechanism. And this is exactly what occurs in the minds of a substantial number of folks here at the beginning of the 19th century. In a way, the rejection of nature as mechanism in favor of the new metaphor of organism was a return to an earlier view, the one of Aristotle, that Descartes in particular had opposed so effectively. But it also served as a major characteristic of an alternative vision of natural science in the immediate post-Enlightenment period, called the Romantic era. Let's see how this all came about. I should let you know in advance that these folks were pretty into philosophy, so there's going to be a philosophical flavor to today's lecture. The Enlightenment view of natural science culminated in the work of the philosopher Immanuel Kant. We met Kant way back in Lecture 1, when we discussed his answer to the prize question of the Berlin Monthly, "What is Enlightenment?" I noted there in passing that Kant had written a book analyzing the limits of reason. The title of the book was "The Critique of Pure Reason." But it's a little misleading if you infer from the title that Kant was out to criticize reason. In fact, he respected it a great deal. His analysis of reason celebrated its power so much that he turned it on itself. He used reason to determine the limitations of reason. Now, this isn't the place to delve into the depths of Kantian philosophy. We have other courses in the teaching company where you can do that. But we do need to get a feel for what Kant said about natural science. That way we'll better be able to understand those who disagreed with his Enlightenment view and wanted to replace it with something else. In Kant's scheme, natural science begins with the data of the senses, and it was dependent on the existence of laws of cause and effect. You began with what the senses told you, and you attempted to capture that empirical information in laws of cause and effect. To do this successfully represented what could be known about nature. So Kant had no problem with the image of Newtonian science in his day. He endorsed the experimental search for the mechanisms of natural process. In fact, Kant felt that there was something quite fundamental about Newtonian mechanics, and for a very interesting reason. You see, Kant believed that our knowledge of nature was conditioned by the mind itself. For example, he felt that the capacity we have to link things together in cause-effect relationships wasn't necessarily due to real cause-effect relationships that existed out there in nature itself. He thought that seeing things in terms of cause and effect was the way our mind works. It was built into the structure of our mind itself to see causes and effects in nature. A little bit like the read-only memory, the ROM, in a computer chip. Causality comes with the mind, like ROM comes with the operating system of a computer. Our use of the mind depends on causality like our use of the computer depends on ROM. And it wasn't just causality. Our ideas of space and number were also built into the mind. That made mechanical description of nature possible, and the mathematical description of nature possible. Now, I realize that this is getting a little heavy, but I want you to see that for Kant, it was important when we try to obtain knowledge of nature that our explanations acknowledge these ideas that constituted the mind. He wanted what he called constitutive ideas, and he felt that mechanical interactions, the way machines work, was a very good example of cause and effect. Push a lever here, I see the effect over there. So for Kant, Newton's mechanical solution of the way the heavens worked and the way matter interacted amounted to constitutive ideas. Now there was another implication for the way Kant saw things. Specifically, Kant also made clear what humans could not know scientifically. These were things that could not be detected by the senses or could not be captured in causal relationships among sense data that were then expressed mathematically. Kant said that all such things lay beyond the pale of the knowable world. The only way to know the world of nature was by means of a natural science that relied on constitutive ideas. There was, he believed, a realm that lay beyond the limits of knowledge, and Kant felt that it was important to acknowledge this realm. But it was not, by definition, a realm about which we can have knowledge. Now, it just might have occurred to you that there's one place we could be going with all this. Here's a question that will tell you what I mean. What would Kant have thought of the new organic relationships of biology? Do they give us knowledge of nature? Are these organic relationships constitutive of the mind like mechanical relationships are? I suspect you can guess that there's trouble ahead. But before we get to that, let me restate the effect Kant's analysis and his vision of natural science has. It's to separate human experience of reality into two non-intersecting parts. One part, the one accessed by our senses, could be made a subject of cognition. We can have knowledge of this part. This was the realm of natural science. The other part lay outside cognition. Here we encounter the supernatural. We can't have knowledge of this realm, but according to Kant, we know it exists. It can, he said, only be apprehended through faith. Now, I think you can see that one implication of Kant's position was that natural science and religion must be kept strictly separated from each other. Natural science dealt with the knowledge of nature. Religion referred not to nature, but to the realm of things like morality, which was not based on cause-effect relationships or among sense data. And we couldn't have knowledge about that. Now, throughout the late 1790s and on into the post-revolutionary era, there were natural philosophers in German universities who continued to promote the investigation of nature along the lines Kant had set down in his work on natural science. Kant was also the starting point for a whole generation of young thinkers in Germany who did something else. He had revolutionized philosophy from what it had been, and his work was being discussed everywhere in the last decade of the 18th century. Really, you had to be impressed. This was heady stuff, and Kant had made a convincing case. But some among the younger generation weren't so impressed that they bought the message hook, line, and sinker. The generation after Kant reacted especially against his fracturing of human experience into two separate and non-intersecting realms. And a good question is, why? Why did the younger generation find the Kantian analysis insufficient? There's several reasons, and there are different kinds of reasons. One is simply that they were the younger generation. Remember, the philosopher of science Jacob Bronowski once observed that members of the younger generation bring with them a certain, what he called, ragamuffin irreverence to their studies. And he felt it was important they do so. Theirs is not to worship authority. Theirs is to question it. That's their job. And that was certainly the case with this generation. Josiah Royce is a great intellectual historian who once described this young generation in Germany by saying that they all thought of themselves as geniuses whose first task was to transcend Kant. And then their second task, he added, was to transcend everybody else. So one reason why they were unsatisfied with Kant was because they were young and out to make a name for themselves. And they had ability. Another had to do with the times. This was the era of the French Revolution and its aftermath. That brought political ferment to France and to all of Europe, for that matter. A new experiment was being tried. The old was out. In fact, the French king was dead, executed by the revolution. What lay ahead as the century came to an end was unclear. But by that very token, it meant that things were pretty wide open. Something new was coming, and people felt that everywhere, especially among the young. It was the dawning of a new era. And that meant that there was an openness to new intellectual possibilities as well. This was particularly true in the German states. The reason why Germans were especially open to new ideas was because it had become clear that the German states were essentially powerless against the might of France. The 300-plus states had no political unity that allowed them to act as one. So in the wars with France that began during the Revolution, it became crystal clear to everyone that Germany was politically impotent. There was one thing, however, that Germans possessed which they firmly believed was much superior to the French. It had to do with that cultural upsurge I mentioned a couple of times. Germans were enormously proud of the intellectual heritage they had been forging as the 18th century turned to the 19th. The one thing they believed was superior to the French, without question, was their unique cultural achievement. In fact, right after the Prussians suffered a humiliating defeat at the Battle of Jena in 1806, the Prussian king said something very famous. I mean, he's known for it. Frederick Wilhelm III observed in a famous statement that the German state, and I think I can remember his words, must replace intellectually what it has lost physically. There was one young natural philosopher of the early Napoleonic period that we need to take particular note of. He was Frederick Schelling, and he was the motive force behind a new conception of natural science, a new vision of what it should be. Schelling was something of a phenom. Young, became a professor at Jena University in 1798 at the age of 23. He was also handsome, eventually stole the wife of another well-known Jena professor. But it was from what he wrote that explains his quick rise to fame. In the closing years of the 18th century and the first decade of the 19th, Schelling published at an amazing pace, and much of what he wrote had to do with how we should understand nature. In fact, from his writings, the German word Naturphilosophie, which literally means nature philosophy, became associated with his position. Turns out, eventually, there developed a cadre of followers to this day. These nature followers are still known by their German name, Naturphilosophen, nature philosophers, followers of Schelling. So clearly, we need to know something about Schelling and his alternative vision of natural science. Incidentally, when I refer to alternative visions of natural science, I mean it in the following sense. There were several alternatives available at the time. I don't mean it in the sense of our contemporary phrase, alternative medicine. We generally mean that the medical theories, with that term, that medical theories and practices are alternative to a dominant or standard view. That's not what I mean here by alternative visions of natural science. The Kantian vision, that of Schelling, and the one that we'll discuss of the writer Goethe, these were not alternative to some standard understanding of natural science that everybody acknowledged. I mean by alternative visions that they were the possible choices one had that you could choose from. Okay, back to Schelling. He began his studies in philosophy and soon, like everybody else, was wrestling with the work of Immanuel Kant. But he also came across the lecture of Kielmayer that we discussed last time. And he was mightily impressed. So he was considering a lot of things as he set out to make a name for himself. In 2 works published just before his appointment to the professorship at Jena, Schelling expressed fundamental dissatisfaction with the cause and effect explanations that Kant required as the basis for our knowledge of nature. Kant's approach assumed, as I noted earlier, that mechanical interactions, the way machines work, was the way that we should think of nature when we're trying to acquire knowledge about it. He assumed that you could regard nature as a machine whose parts interacted, as machine parts do, and they do that by passing their effects from one part to another. There was something about this that Schelling thought was flawed, and it was this. Kant's analysis applied to external nature as if one was observing nature from outside. From his reading of Kielmayer, and for other reasons as well, Schelling became aware of the new sense of life and its uniqueness of living things, this uniqueness of living things that we explored in Lecture 13. In fact, he came to the conclusion that living things were more basic than machines. Nature, he thought, was more like an organism than a machine. One of the ways he justified this conclusion is interesting. He said organism preceded mechanism, he argued, because if you negate the organic, that is, if you kill an organism, then what you're left with is a mechanism. Chemical interactions that will ultimately cause decay and disintegration. But you can't go the other way. You can't negate mechanism and end up with organism. If you negate mechanism, you get chaos. And that's the very antithesis of organism. That's highly complex order. So given that nature is full of highly complex order, already we know that, organism must be prior to and more fundamental than mechanism. That's how he thought about it. Well, let's ask ourselves, if we start from the premise that nature is like an organism, what are the implications of that? Well, let's think about organisms. One of their important qualities is the way they integrate a complex set of characteristics into a unified whole. It's not like mechanism where one thing causes another, that causes another, that causes another, until you get to the end effect, which is the purpose you build the machines for. That's simple compared to organism. In an organism, the heart pumps the blood that carries oxygen to the body, including the heart, which needs it to pump the blood. You get the picture. There's mutual causal interaction. Living things are both causes and effects of themselves. And organisms bring it all together into one unified whole. As for humans, we do something more. We integrate all that and include the experience of the mind as well as all the physical characteristics. Organisms represent integration into a living whole with no aspect of reality left out. What occurred to Schelling was that this insight provided him with a means by which he could overcome Kant's fracturing of human experience into 2 separate realms. If nature was an organism, then knowledge of organism would include knowledge of nature as a living whole. There wouldn't be, as Kant taught, 2 separate realms, only one of which was accessible to knowledge. For Schelling, our knowledge of nature reflected the whole. There wasn't any separate supernatural realm hovering out of our reach above the natural realm. There was only one realm. Now, admittedly, all this meant that natural science would become a much broader enterprise than it had been. It wouldn't be confined only to the data of the senses and the laws of causality, as in Kant's scheme. Schelling endorsed Kielmayer's notion that nature had an inner purpose that was reflected in the laws that living things follow. But he went farther. For Schelling, knowledge of nature included considerations of beauty, too. He didn't believe that in understanding nature, aesthetic considerations were irrelevant. They were, in fact, an essential component of the creative cognitive process for him. Same for morality. Schelling wanted to give, as he once put it, wings to physics, bring it all together, everything. On the point about nature's purposefulness, I want to be a little more specific. While Schelling certainly agreed with Kielmeyer that the laws of development of living things operated simultaneously at different levels, in his earliest writings, he seemed not to entertain the idea that species had actually developed over time, that there had been an actual evolution of species. But he came to believe this, even if it was an evolution of a specific kind. He came to believe that nature's inner purpose, where species were concerned, was moving toward an endpoint, a kind of archetypal ideal. What happened in history was that nature was pulling the species toward the realization of this ideal. Once again, nature was a purposeful place. Because Schelling didn't want to stop with the data of the senses and causal laws, Schelling was sometimes portrayed in his own day, and also by historians since, as if he only respected speculative thinking, that he had no respect for experimentation or the empirical data of the senses. That's simply not the case. He did want to know about causal relationships. He just didn't want to stop with them. For Schelling, it's not that we know nature because our minds are structured a certain way, as it is for Kant. We know nature because we're part of nature. We recognize nature because we have first-hand knowledge of it. Knowing nature is akin to knowing oneself. So the nature that is known by human souls is best comprehended as itself a world soul. Now, because of this inclusiveness on Schelling's part in his nature philosophy, because it included more than merely causal relationships among empirically gathered data, because it included considerations of beauty and morality, because of all this, Schelling's vision of natural science has been called romantic science. There's no mystery here. You can see why it's called romantic. And romantic science became a very popular choice among many of the younger generation in the early years of the 19th century. It stood as an alternative choice to the continuing Kantian view during the first 2 decades of the 19th century. Remember, as I've noted on more than one occasion so far, there was as yet no consensus view about the meaning of natural science. There was no established scientific community in our sense of the word during this period. There were, of course, academies and societies of natural science, but membership in them was by and large a pretty exclusive affair. And even then, there could be a lot of disagreement, say among those members who preferred Schelling's vision to those who preferred Kant's. And since there wasn't yet a recognized practitioner of natural science, those interested in studying nature included individuals with a variety of professions and outlooks. Let me quickly review the significance of Schelling's nature philosophy. The great attraction of Naturphilosophie to many young minds of Schelling's generation lay in its insistence that nature be given its own integrity and not be made overly dependent on the formal structure of our minds, as Kant was seen to have done. I remember reading one young natural philosopher who had come to Schelling after having read Kant, and he wrote to a friend, "I have finally found in Schelling something real." And he meant by this that Kant seemed to set the structure of our minds prior to things so that it dictated what nature had to be. What was not accessible to that structure couldn't be known. It was as good as unreal. Schelling didn't do that. He didn't divide things into 2 domains like Kant did. The one nature we know is the nature that really is. So Schelling's new vision for natural science won him important admirers from many quarters, including numerous scientific disciplines. Many physicians in particular found his emphasis on the organic especially appealing because they felt that healing was impossible without seeing the body in intimate connection to the soul that inhabited it. And one of Schelling's devoted followers, the zoologist and nature philosopher Lawrence Oken, became an extremely important figure in German natural science. He founded the journal Isis, one of the first forums for opinions of scientists and non-scientists alike. Oken was also a key figure in the establishment of one of the very first open organizations of natural science. It called itself the Society of German Natural Scientists and Physicians, and it held its first meeting in 1822. We're going to learn more about that organization in Lecture 28. But by the end of the third decade of the 19th century, Naturphilosophen, natural philosophers, found themselves more and more on the defensive. For one thing, the followers of Kant naturally tried to defend their mentor's position from Schelling's criticisms. For another, Schelling's opponents had some success in misrepresenting his claims as hostile to empirical investigations. And an increasing number of natural philosophers resisted Schelling's call to reformulate their mission to include philosophical issues, preferring instead to restrict their activity simply to figuring out how nature worked. And the result was that by 1825, there were relatively few who identified themselves as Naturphilosophen, still around in the German states. Romantic science had become less and less a live option by then. Well, I want to conclude today with a brief consideration of one more manifestation of Romantic science in this period, the work of the novelist, poet, and playwright Johann Wolfgang von Goethe. By the turn of the century, Goethe had already enjoyed great literary fame for his novels. In addition, he had a celebrated position in the court of Duke Karl August in Saxe-Weimar, and among his many interests was natural science. His passion for natural science showed itself first in his work on morphology. That's the study of the form and structure of plants and animals without regard to their function. Like Kielmayer, Goethe looked for regularities operating at different levels in the phenomena that he observed, and he found them. But he came to believe that finding them took a practiced eye. You had to include more than logic here. You had to let yourself, for example, be informed by conceptions of nature's beauty as well, if you were going to detect nature's subtleties. But if you practice careful observation, you could learn to identify the basic forms lying behind the differentiated structures that were used to classify things. For example, Goethe concluded that the leaf represents the essential scheme underlying the parts of a flower, that is, the stamens, the pistils, calx, and observable leaves are all modifications of the basic leaf pattern. Not everyone could see that when they looked at a leaf. The other scientific subject that fascinated Goethe was optics, and here he took on no less than Isaac Newton himself. He knew about Newton's work in optics. Newton had claimed that colored light was produced by a prism because the prism separated out the colored rays from the so-called white light. It bent each colored ray through its own particular angle of refraction. But Goethe didn't come at the subject like Newton had. He held the prism up to his eye and looked through it. And when he did so, he was astonished to see that the white wall behind the prism remained completely white. The only color he saw was at the boundary of a shadow or at the boundary of some dark surface on the wall. So Goethe immediately concluded that Newton had been wrong in his explanation of color. Clearly, color was a product of the mixing of light and dark. Now, had Newton been alive, he could easily have explained from his own theory why Goethe saw what he did. But Goethe's objections to Newton went very, very deep. Like Schelling, Goethe didn't like separating himself from nature. He didn't like to think of himself as outside nature, looking in, trying that way to come to know nature. He wanted to be part of the nature he was trying to know. Newton, he thought, ignored the subjective experience of the observer. He examined it only from the outside. Goethe wanted to include the subjective experience, including, incidentally, nature's aesthetic impact, again, like Schelling. This difference between Newton and Goethe meant that there could be no meeting of the minds. The followers of Newton were very critical of Goethe's color theory, much to his dismay. I have to tell you that in the course of writing on color theory, Goethe raised a number of important and enduring questions about the impact of the subjective perspective of the investigator on the knowledge that you acquire. Goethe's observations in this vein have continued to occupy philosophers of science ever since. Well, there we have examples of choices that confronted the natural philosopher of the first few decades of the 19th century. I've described options that were readily available in Germany, the Newtonian outlook as articulated in the Kantian tradition and the romantic visions of natural science of Schelling and Goethe, but England had its representatives of these choices as well, and at least somewhat later we find Newtonian and romantic science in America as well. France? France is a special case where at least romantic science is concerned. There were glimmerings of it there, and we'll meet them. But in our next lecture, we'll meet a thinker who was exposed to the German romantic spirit in natural science as a student, but who turned away from it as he went to France to explore the world of prehistoric beasts.